Hi. So in this video, I will summarize my learnings or studies that I have completed today. I will basically, this is a note to myself so I can review it later. So I will try not to bias anything. Maybe I will talk a bit in Bangla, a bit in English, so it's not a problem. So basically, I am studying a book called the 100-page language model book, and from the first and second chapter is introducing me to fundamental concepts before moving into actual language modeling. So one of the concept is called byte pair encoding. So byte pair encoding is a tokenization technique. So for that, we need to know what is actually tokenization. Tokenization is a process to split a corpus or a document into smaller units so that machines can then process those units. For example, computers cannot understand words, they cannot understand human languages. So, to run machine learning on human languages, we need to somehow convert the text into numbers. So, converting text into numbers requires breaking the documents into smaller parts and maybe assigning. There are many other techniques, for example, bag of words, word embeddings. Mm, so, before that, we need to do tokenization. So, traditionally, until 2016, 2017, people used to use word to vec for word embeddings. So, most of the time they just used to break the whole vocabulary into by words. I mean, if I have a paragraph, I just break them with the space, and each word we call that a token. But there are some problems with breaking by words. So for what kind of problem? The problem is that a language can have many meanings, and it is literally impossible for one vocabulary to contain all kinds of phoneme or morpheme of one word. For example, let's say a word called do. It can have some kind of form like do, does, doing, did. So if our original vocabulary doesn't contain all the form of do, it basically treats that as an unknown word, which basically impacts the final result of the model. So this is one of the limitation of breaking a document by words, that the model cannot predict properly on unseen words. So breaking into subwords actually helps us to perform better on unseen or unknown words as well, because not only unknown words, maybe on misspelled words, a word that mm, may be similar to a word that was in my original vocabulary, but somehow it got altered. So so of course, for the better context of the language model, breaking by word is not the feasible one. Breaking by subwords is more preferable. Another reason to not use words and use subwords is the computational resources. Mm, to actually include all words or all forms of languages of one language into the vocabulary, it is quite impossible. Or if you force it, the vocabulary size will be so huge, training a model will be very computationally expensive. So, but by only storing the substrings or subwords, we can have we can store we can cover like most of the range of one language, but still in a comparatively lower amount of memory. So this I basically explained what is tokenization and why choose subword based tokenization. Byte pair encoding is one of the way to achieve subword units. So let's assume we have a corpus, a toy corpus, which is this sentence. This is the Hugging Face course. This chapter is about tokenization. This section several tokenized algorithms. So the first step of BPE is to normalize the given document. So as you can see, there are uppercase, lowercase, and many representation of the characters. So the first step is to normalize. That means we have to convert all the words to lowercase and replace the special formation with more natural way we write the characters. So after normalization, we do something called pre-tokenize. That is basically breaking the whole paragraph word by word. After breaking the pre-tokenization also includes removing unnecessary things like full stop, is, the. So these are not that like prepositions prepositions, tense forms are not necessary for the training data. We only care about the actual words. So we remove those unnecessary prepositions, and we only keep the actual words and the count for them. So the first step is to build the initial vocabulary. After pre-tokenization, we count the actual words, then we build the initial vocabulary. Initial vocabulary is, before building the initial vocabulary, we actually break each word to its character level. Like Hugging Face become HUGGING and so on. And we make it a set, so the duplicates are removed. Once the duplicates are removed, we take all the characters and put it inside our initial vocabulary. And then after after building the initial vocabulary, we from the initial split, we take pairs of the tokens. So HU plus UG plus GG, GI, and so on. We take each pair and count. If we happen to encounter a duplicate, we just increase the count. So by that, we actually reduce the uh, by merging the pairs, we get which pair actually appears most frequently. So here we can see that LE appears most frequently. We assume that is our new token. So since LE appears most frequently, we replace all the instance of LE. For example, here the instance of LE, we remove them and replace with the single token that lay, and we enter the newly chosen token to our initial vocabulary. From the next step, we actually just keep repeating the same step again and again, but for the remaining tokens that we have. So we again merge, keep making pairs and find the most frequent one. And here we can see LEA. LEA plus R is the most frequent one, and we find the same pattern and replace them with a new found token and add that new found token to our vocabulary. So how many times we continue this loop? We continue to n, and n is basically defined by the vocabulary size. Vocab size. So vocab size, it means traditionally it's 32K. I mean, people tried it multiple times on many languages, and they said that if you keep the vocabulary size to 32K, that is enough to actually uh, contain all the words of a single language. So, and another factor here to note here is the fertility rate. Fertility rate. Fertility rate basically just means on how many tokens we should break a word. I mean, so there are some factors: the vocabulary size, fertility rate, mm, that actually controls how many times we will run the loop and keep breaking our splits and merge to increase our vocabulary. So keep in mind, this is just the tokenization phase. Byte pair encoding is just one method of tokenizing so that we build the vocabulary, so that for any unknown words in the future we can actually connect which words are most similar to the new word that we have in the problem. So we will maybe study that on some other day. So that was byte pair encoding. And another topic that I got into today uh, is the basics of language modeling. So here actually the author actually started implementing a counter based language model. So I will just give a quick summary. I didn't even finish it, but let's give a quick summary. A language model is nothing but that given a sequence of tokens, it predicts the probability of the next token. So let's say we have a vocabulary that includes R, cool, language, and models, and useless. And if we ask the model, what is the probability of R against the sequence language models are? This is it, 0.01. So when we ask the model about, give it a sequence, or that we called the input sequence, context, or prompt, the model actually tries to predict mm, the most probable token that comes after the prompt. And in this chapter, they implement a language model called counter based language model, that is nothing but just doing some statistics on the available words in the vocabulary. So we will continue that from the next time.